of structural engineer, let's talk about why today's lecture is not so much about concrete. It's about structural engineering, and I wish that others would also join. So first of all, we want to see that what are the structural engineers doing? Why is it so important? The main thing is that we are the one, or the structural engineers are the one who do the creation of the safe environment for other people to live and work, and everything around you that you see that other people use, or the other people use, or other people, yeah, maybe quick introduction. You're from? Which country? Myanmar. Yeah. Oh, yeah, Myanmar also. Come in the front, come in the front. Okay, so nothing can function if the structural engineers do not do their job. You do not know how important it is. The public does not know also how important structure you cannot think of anything that can work without structural engineers. The bridges, the buildings, the transmission towers, the water tanks, the dams. Just think of anything that is created by man. It requires structural engineer because it has to be built. It has to stand the weather, earthquake, wind, dead load, light load. If it has to support anything, structural engineer must be involved, right? So that's why it is very important. So every other professional depends on structural engineers. They need structural engineering to do their jobs. If it's a mechanical engineer, they need a plan to construct something. We need to design that plan. If it's electrical engineer, they need power transmission towers. We will be designing the power transmission towers for them. The telecommunication engineers, they will need buildings, so everybody will need something, some space to work. And who designs that? You, the structural engineer. So it's a very, very important profession. So if you did not know before, you should know that this is the basic profession that everybody will need. So transportation, telecommunication, electricity, water, irrigation, mining, industrial, housing, public buildings, everyone, structural engineers are involved in doing this work. Look at these structures from old times. Somebody designed that. You may not call them structural engineer at that time, but somebody with the same thinking, same skill, same intention, they did that. They used to call them master builders at that time, right? People who are both the architects and engineers and builders, everything put together. So just like philosopher, at one time they had all the knowledge. They were the scientists, they were the mathematicians, they were the physicists, they were chemical, everything, one person, philosopher. So great philosophers knew everything. Same thing, great builders knew everything about building, including design, materials, everything. So at that time, there was no structural engineering field, but it started from that old times. Then modern times. Now, what is this? Okay. Why it is called Eiffel Tower? Sorry? Because it is named after the designer. Eiffel was the guy who designed it. So you can imagine that the designer's name is now defining Paris. So if you look at this, you know it's Paris. And Paris' whole city is planned around this. No building is supposed to be higher than this tower. So a structural engineer did that, a gift to Paris, and he also designed one more thing. Which was that? Statue of Liberty. Same designer, same structural engineer, also designed Statue of Liberty for New York and sent that as a gift to the city. So one structural engineer defined two main icons in the world, most popular icons that you can immediately see: Statue of Liberty and Eiffel Tower. Both structural engineers based on a structural engineer's design or dream, and they are pure structures. Look at that, skeleton and all of that. Other important structures, Hoover Dam. You can see everywhere the main, I would say, icons of any development are big structures. When somebody says, when they talk about Dubai, what do you remember? Burj Tower, right? So, Burj Dubai structures, again structure engineering. Anything you can think of, it all comes back to structure engineering. What is this? Yes, but where? Come on, don't you watch the X-Men movies? X-Men? Remember they go on the X-Men and they dismantle it and fly it away? Come on, you don't know where is it? What is it? San Francisco, right? So the city of San Francisco, because Golden Gate Bridge, one of the most beautiful bridges in the world, right? Structural engineers made it. It became the symbol of the city or the country, and it is shown in every movie. They show these things, right? Especially Golden Gate Bridge. They break it. They, whatever they want to show, they show the Golden Gate. So again, structural engineering. What is this? CN Tower in Canada. People go up there and they say there's a restaurant, there's a viewing gallery. So structural engineers again. So most of the big things that you see around in the world, they're all structural engineering marvels. They are the products of structural engineering at the very best, right? So none of these could have been done or created if you didn't have structural engineering. Look at these towers, these skylines, these buildings, everywhere. Everything behind structural engineers or technology that structural engineers do. None of this could be possible without what you are going to learn here. Can you design this now? If I give you this building, can you do that? Why not? You already graduate, civil engineers, right? Yeah, but you see, okay, we'll see. Okay, bridges, all kinds of bridges. Really long, beautiful bridges everywhere. So just think of anything that is being made and which is visible, which is iconic, which is great, which represents city, which represents progress. It all comes from structural engineering. Look at the things that are coming in the future. Look at this tower. Look at this tower. Buildings. We will talk about tall buildings next course. We will talk about designing of such things, right? So tall buildings now, people expect you to design things like this that keep twisting, keep moving, right? So again, structural engineering. Where is this? Do you people know anything about the world? This is the world's longest and highest cable stayed bridge in France, right? It's higher than Empire State Building. These towers are really, really tall. And this is a beautiful bridge, just fantastic. And again, structural engineering. Okay. Where is this? Okay, good. No, you know something. Also, again, this is the interesting bridge. It is suspended, it is anchored by the cables, it is movable, and it has its own character. But again, structural engineering. You cannot think of anything that is right from with the wind. Look at that. Beautiful structures, exposed structures in this one. There is one similar building in Bangkok now, right? But that's fake. That's not real. I mean, it's number 2, it's copy. Because it doesn't have a structure of a diagrade. We call this diagrade. This structural form is called diagrade. So diagrade is a very powerful structural form, but it's the one in Bangkok is not real diagrade. They just put it outside, make it look like that. But these are real diagrade structures. We will talk about them in next semester. What is this form called? Anyone? If you get it right, I will buy coffee for you. Yeah, shell, but what is the name of this shell? This one. Or this one. Anyone? Coffee. Omicron, 1 coupon. This is called hyperbolic paraboloid. You have no idea, right? Yeah, you should know. Hyperbolic paraboloid. This is the form, the name of this form. This is a very efficient structural form. Very thin shells can be made. It's a beautiful thing, It's called hyperbolic paraboloid, right? And it just sounds good if you know this. You can impress people like this. So what is it called? Can anyone pronounce it?
Hyperbolic paraboloid.
Yes, hyperbolic paraboloid. So this is the form. This is very, very efficient structural form, especially in concrete. And again, who did that? Structural engineers. You know, one thing is common in every Olympic, since the beginning, Olympic Games. You know, you follow Olympic Games or not? Olympic Games. Do you see anything? Not so much, right? Please, come on, people. Do something. Anyway, Olympic Games. Who is present in every Olympic Games since the beginning? Structural engineers. Because they design all of the arenas. When they hold the Olympic Games, they have to design these huge arenas and domes like this Thammasat. You know when they make all of this, 1998.